Welcome to Martin's Institute of Teaching. So in this video we're going to be working with block, word, and byte. And we're going to also use a little bit of string out, and we're also going to work with compare. So let's jump right into it. So the first thing I wanted to tell you is that, well, I know we've worked with block before, dot block. So here we're going to say num1. Then we're going to declare this as a dot block of 1 byte. And all that means is that, whoops. So what this does right here is it's declaring in memory, a block of memory that is 1 byte long, and that's what number 1 will be. So this just generates a block of 1 byte long, a block of 1 byte. So now if we also wanted to say num2, another variable, we could say dot block 2. And all that does is it generates a block of 2 bytes. And, oh, you know what? I can't do that. It's supposed to be a semicolon. There we go. So this command here, dot block 2, is going to generate a block of 2 bytes. So, and with the block command, we can dedicate however many bytes we want our variable to hold. So we could say num3 and say dot block like 512, and that's used for if you want to create an array or something that needs a lot of space or a lot of bytes. So that just generates a block of 512 bytes. Okay, next. So I'm going to read this one right out of the book. This is from Computer Science 4th edition, J. Stanley Warford. And the way he describes the word command, he says, like the block command, the word command generates code for the loader, but with 2 differences. The first, it always generates 1 word, 2 bytes of code, not an arbitrary number of bytes. Second, the programmer can specify the content of word. So what does word mean? So let's go ahead and declare another variable. We're going to call this num4. That's going to be a dot word, and we're going to call that a 2. So what does that mean? What this means is that this variable num4 is 2 bytes long. And num4 right now, we've already set it equal to 2. So let's say in Java, you would say something like int x, and you could say equals to 2. Essentially, that's kind of what we're doing here. This is somewhat the equivalent to this, where you're declaring a variable and you're instantiating it with the value 2. Here, we're instantiating num4 with the value of 2. I could also change this to 20, to 0, to 1. It's pretty convenient that way. So right now, I'm just going to set it equal to 1. So what that does is it generates a 2 byte word of value 1. Okay, so now let's see anything else. Oh, the byte command. So let's just say letter 1. And for this, I'm going to use the byte command. So I'm going to say dot byte. Let's see, what do I want to call this? Let's call it, I don't know, A. So this just, and I'll read this one straight from the book too. So the byte command works like the word command, except that it generates a byte value instead of a word value. So there you go. Of course, let's see. So let's see, this just generates a block of 1 byte. Okay, so now let's go ahead and do this. So let's go and say main. So right away what I want to do is I want to load a value into num1. So let's load the accumulator with 1 immediately. and I want to store that value in num1 directly. And then after I do that, I want to print that out. So I'm going to say deco num1 directly. And so always after you do that, you need to end the program. So we're going to say stop and then dot end. And so if we run this, what it's going to end up happening is we're going to print out the number 1 over here in the output. So let's go ahead and build this program, and now I'm just going to run it, and we get 1 over here. We could also change this value. We could change it to 2, and you'll get 2. Okay, so we loaded 1 into the accumulator, we stored it in num1, and we printed out num1. Now let's go ahead and let's start playing with num2. So here, same thing, load the accumulator. Let's load the accumulator with 10 immediately. Store that in num2 directly. Now we're going to deco out num2. But actually, you know what? If we did that, what we're going to get is the value 1 and 10 right here. So if we build this, oh, whoops, forgot. So we need to say directly. Yeah, you need to tell it what type of, oops, come on, there you go. Now it's a line. Yeah, you need to tell it what kind of addressing. So now we'll build it and run it again, and we get the value 110, and you're like, well, that's not right. And you're right, it actually is correct, but it's sloppy because we printed out both the numbers right next to each other. So we're going to separate them. So instead of writing byte.a, I'm actually going to turn that into a space. And now we're going to say char character out, which that's what charo means, and we're going to say letter 1 directly. And so when we do this, it should hopefully put a space there. Let's see. Boop, and there you go. Just like that. Real cheesy easy. Okay, so now let's see. Okay, let's say we want to compare two values. So now let's show you how to compare two values. We want to compare num1 and num2. So let's go ahead and we're going to say right now we currently have loaded into the accumulator is the value 10. So let's compare both values. So we want to load into the accumulator num1 directly, and we want to compare the accumulator to num2 directly. So we want to tell it to bridge somewhere, to go do something if this is true. So we want to say branch if it's greater than. So if num1 is greater than num2, we want to tell it to go somewhere. So we're going to say branch to let's call this true, and we're going to, but we have to declare that spot first. Okay, so let's call this true. And let's also show you while we're at it, because when we branch to true, we want to say something, but we need to create a string first in order to do that. So let's go ahead and create a string. So in order to create a string, you have to use the ASCII addressing mode. So let's go ahead and type in here, let's call this message1, so msg1, and we're going to do .ascii, and then we're going to use quotes, and we're going to say num1 is larger than num2. And to end, let's see, to end a string, you do backslash at lowercase x 00 and quotes. But I'm going to put a backslash in here because I don't want this to print out right next to any of the, I don't want it to print out right here. I want to print it out below it. So if that's true, now that I've created this this string, I want to print it out. So the way I print it out is I come down here, and I say string, which is stro string out, and then we're going to get the message 1, and we're going to print it out directly. And so if that ends up being true, if this is true, that num1 is greater than num2, it's going to branch to true, which is true is right here. And after this branches out, I want this to stop. So I want it to branch to stop. Or I'm just going to say stop, or end me. We'll call this end me. Go back over here. And we're going to do an unconditional branch. So we'll say branch to end me. Okay, let me pause this real quick. Okay, so now if this happens to be a false statement, we want it to do, so if we, now let's come down here, so let's just say branch if it's less than. So if it's less than, we want to call it false. And let's go ahead and create that. We go back, let's create this right here, say false. And we're going to do another string over here. Let's create a second message, message 2. Which is going to also be .ASCII. And we're going to do \n as well. And then we're going to say num1 is not larger than num2. We're also going to end this. That's how you end strings. So here we're going to say string out message 2 and branch to end me. Okay, so now that we've done this, right now currently num1 has a value of 1. Num2 has a value of 10. So at this point, num2 is larger than num1. So when we come down to this comparison, it's going to say load the accumulator with num1. So we're putting 1 immediately into the accumulator, and we're going to compare that to num2. Num2 happens to be 10. So what this statement right here, branch if greater than, what it sounds like is num1 greater than num2? And if that is true, we're going to do this command right here. Now this, I could put whatever I want right here. I don't have to put true. I could actually put false or go to. Whatever I put right here, this branching statement, this right here is where it's going to branch to. So this branching statement, if it's true, if it is a correct statement, if num1 is greater than num2, if it's greater than it, it's going to branch to true. So it's going to look for true wherever true is in memory, and it's going to jump to there. So since I set this as true, it's going to jump to true right here. So it's going to jump to here if num1 is greater than num2. So it's going to come here and it's going to load this, it's going to execute this first command. And whenever you do these, you have to have something right here, because if I leave this blank like this, it'll give you an error. So the very first command is I'm going to do this string out, which is message 1. If actually num1 is greater than num2, it'll branch to true, which here's true, and it's going to execute this first command, which is message 1. Over here, message 1 is num1 is larger than num2. And then after it executes that message, it's going to do an unconditional branch to end me. This branch right here, since it has nothing after it, as soon as you get to this command, it automatically will branch to whatever this address is right here. Since this one is end me, it's going to look for this, and it's going to find it over here, and it's going to branch straight to here. And as soon as it branches to end me, it's going to execute to stop. It's going to tell Pep8 to stop reading the code, and then it's going to go to end, and it'll end the program at that point. Now, if we come back here, and num2 is actually, let me pause it. Okay, so let's see. Sorry, I had to take a quick break. Now let's see. Oh, okay, so we're on the false part of it. So if we go into here and num1, we're going to compare num1 to num2. First thing is you're going to do this command, which is going to say, okay, is num1, you're going to compare num1 to num2. If that happens to be greater than, you're going to go to true. If this statement is not, if if num1 is not greater than num2, this will not execute, and it'll go to the next command. These commands will only execute if it is greater than. So if for this one to execute, it has to be less than. So num1 is compared to num2. If it is less than, if num1 is less than num2, it's going to go to false. And false, it's going to jump down to this one, and it's going to execute string out 2. And then it'll branch to enemy, which it's going to come down here. You really don't need this because after you execute string out 2, it's just going to go down to the next line. So I don't need to put this here. I'm just putting it there just to show you the unconditional branch. So let's go ahead and build it and run it. So tell you what, why don't you guys think about what's going to happen? Yes, which one of these will happen? I mean, and once you think about it for a little bit, go ahead and unpause the video and see if you got it right. So I'll give you a second to pause it. I assumed you paused it, so let's see if you got it right. Ooh, so it says num1 is not larger than num2. Is that what you guys guessed? Well, I hope so. So now let's go ahead and change that. Let's say num1. In this case, it's actually, let's say it's actually 4, and let's say num2 is 1. So let's see if that changes that. So at this point, num1 is actually larger than num2. So since num1 is larger than num2, it should go to true because num1 is greater than num2. So let's see if it's going to print out num1 is larger. So let's build this and run it. Oh, num1 is not larger than num2. What on earth is going on? I get the same one. You know what the problem is that it's a dot block 1. I need to set that to block 2. If you do that, then you'll get the right answer. So let's go ahead and build this and run it. And then you get num1 is larger than num2. The problem is that it's just it's 1 byte, and if it's only 1 byte, it's not going to give you the correct value. So if you're going to put integers in there, you need 2 bytes. So let's see. So we've got 4 and 1. So num1 is larger than num2. So so far we've used the compare. We've used branching statements greater than, branching statements that are less than, and string out. So let's see. What else can we use? Oh, okay, so here. We haven't used word. So for word, let's go ahead and create another statement. So here we set word is equal to 1. Let's go ahead and set word equal to, let's say, 100. Now let's try this another one. So let's go ahead and we're going to load the accumulator with num4 directly. Now we're going to compare that to right now num1 is 4, so let's go ahead and set that to 40. Now let's go ahead and set num2 equal to 110. So we're going to go ahead and compare this. So let's compare num4 to num1 directly. So we have a problem because as soon as we execute this command, it's going to branch from here to these guys, and these guys, both of them, send it to n, which is going to jump to here. So in order to execute these, we actually have to send it back to over here. So let's go ahead and instead of saying go to end me, we're going to send it to let's send it to test me. Test me. And by the way, if you put like a capital here, it's going to read this as an error. These have to match exactly. So, okay. So now, if, let's see. So, oops, here we go. And so once this executes, so it's going to load the accumulator with num4. It's going to compare it to num1. And actually, we're going to need another string. So let's see. So let's say it's branch if it is. Well, let's say if it's greater than, and we're going to branch to. Should we do true? Well, we can't do true because true is printing out message 1. So let's call it true 2. Whoops. 2. And let's put true 2 down here. And here's where we're going to do another string, but we only have 2 strings, so let's go ahead and create a third string. So MSG3, another ASCII one. Let's do \n, and let's say, well, actually this is num, we're comparing it to num4, so let's say num4 is larger than, we're using num1? Yeah, num1, so larger than num1. Now let's go ahead and end this statement, so, okay. So at this point, num1 is equal to 40, and num4, where are you at? Num4 has been set to 100. So when we test this, it should go to true. So let's go ahead and, let's see, error must have mnemonic. Oh yeah, whoops. Let's get rid of that. Because we actually forgot. So here, let's see, where's it at? So at this point, when it goes to test me, it's going to load number 4 into the accumulator, it's going to compare it to number 1, and it's going to branch to true 2. This should be fine because num 4 is 100 and num 1 is, I think at this point it is 40, so it should be true, and it should jump down to true 2, but we didn't put anything here. And like I said before, if you leave this blank, you're going to get an error. So let's go ahead and put a space between those. And let's go ahead and say string out message, is it 3 or 4? Message 3. Message 3 directly. And at this point, let's see, we want to, what do we want to do? At this point, we could just go ahead and branch to end me. Okay. And from here, it's just going to jump to here. I don't need to put this in here. In fact, just to show you that I don't, I'm just going to go ahead and comment that out, and then we'll run it again with this not commented out. So let's go ahead and build it, and let's run it. So we get num1 is 40, num4, this is num4 is 110, so num1 is not larger than num2. And what happened? We didn't do what I wanted. Let's see, where did we go wrong here? And this, you know what this is really good for? Let's step through this whole process. So let's see, we're going to step through. It's going to jump straight to main. So here we're at main. It's going to load the accumulator with 40 immediately. It's going to store the accumulator with num1. It's going to print out num1. Oh, by the way, here's the accumulator. You can see we stored 40. And there you got the 40. We printed it out. Now it's going to load the accumulator with 110. Then it's going to store the accumulator at num2. It's going to do a character out with a space. So it's going to put a space here. It's going to deco out number 2, so it'll put 110 over here. Now it's going to load the accumulator with number 1. There's the accumulator, 40. And it's going to compare it to number 2. Let's see, number 1 is 40, comparing it to number 2. Oh, you know what? That's what the problem is, because it's checking. It's going to say, is num1 greater than number 2? Well, no, it's not. So it's going to it's going to branch to less than. So from here, it's going to branch to false, and that's why. Okay. So it branches to false. It's going to do its string out branch 2. Then it's going to go to end me. That's why we never saw the rest of it. So it's okay. So it's going to branch to end me. Gets to end me. And it's going to hit here. It's going to stop, and it's going to end it. And that's that. So let's go ahead and force it to go to true 2. So in order to do that, we need num1 to be greater than num2. So let's go ahead and switch this to 60, and this will be 50. And now we should go ahead and be able to go through all of it. So let's build it and run it. And here you see here's num1, which is 60, num2 is 50, and it says num1 is larger than num2, which is true. And it says num4 is larger than num1, and that's true because num4, we declared as 100 here. And let's see. So I think that's pretty good for now. We did quite a few in this video, so the next video I'll just do another video similar to this where we do a bit more of the coding with it. So yeah, I hope this video helped you out. You can see quite a few things were going on here. I hope it wasn't too confusing, but don't worry, I'll make more videos because I think repetition is fantastic, and I wish teachers would do more repetition than just trying to speed along through classes, which a lot of them do, and I think that's a detriment to the students. So teachers out there, do yourself and mainly do your students a favor and do way more repetition. Repetition is what really drives home the material. But then again, they also do say that you should just kind of teach it to yourself, which I've seen a lot of teachers do, which I don't like. Anyhow, I hope this helped you guys out. So if it did, great. Don't forget to click like and subscribe, and good luck in your classes.